Okay, so in addition to the base version of new and delete, there's also a version of new and delete you have to use if you want to make an array. And just for my shorthand, I'll refer to these versions of new and delete to an open and close bracket after it, or delete with an open and close bracket after it. And I'll just read this as new array and delete array for simplicity. Okay, so new array and delete array. When we want to make an array, then we need to use these brackets in addition to the new and delete keyword. So if I want to make an integer array, then I have to add the brackets after the type that follows new, so new int, and then the brackets mean I want an array, and then the number inside the brackets mean how big I want the array to be. So I would read this as int star array equals a int array of size 5. And then later, if I want to deallocate this array, then we would use the delete keyword. Right after the delete keyword, we have open and close brackets. We don't need to place any size inside these brackets. This just tells delete we're deleting an array, not a single int, array events. And then followed by the pointer of the array we want to delete. Okay, so a pretty simple notation. Anytime we want an array, at the end of new, we're going to have brackets with the number of elements we want in our array. And anytime we need to delete and free the array, then after the delete keyword, we need to include this open and close bracket. Okay, here are some more examples. Let's say I want to allocate 1,000 doubles. Then I would say double star D, right? I just need a pointer of type double. And I can set this equal to new double. And then very end here in brackets, I put the number 1,000 to indicate that I want 1,000 doubles. And then later to delete this, I would say delete array D. Okay, if I wanted to allocate n structs of struct B, then I would say new struct B array of length 10, right, with 10 in brackets at the end. And then when I wanted to delete that array, I would say delete array B. Now, an interesting thing here is since B is now pointing to an array, when I want to access one member of that array, I can use array notation and say B 1, and then access the ball field and set it to 0. And this would just set index 1 of this array's ball field to be 0. Let's say I wanted to allocate 5 instances of class R in an array. So I would do that by saying new R and then put 5 in brackets at the end. Okay, now the interesting thing here is when I do this, it's going to call the default constructor on each element in the array and set each element equal to 10. So if I called on the 4th element of this array, the print member function, then it's going to print out the value 10. Since all members, all objects in this array that were allocated all got initialized to have the same value of 10. Okay, and then when I want to delete this array later, again, I say delete array R. And they all get deallocated, and the destructor will be called on each one. Right, and this just reiterates this fact. When I call this new R array of size 5, the constructor in this object get called on each one of these objects that's getting created. And likewise, when I delete it, the is called on all 5 objects as well. Okay, an important detail here is that new array always and only be paired with delete array. Whenever new uses brackets, it must be paired with delete using brackets. Okay, this is critical for ensuring proper destruction of objects. If you disobey this rule, it's undefined behavior, and maybe it'll work some of the time, but maybe really horrible things will happen inside your program, and you won't know why. So you always need to pair new array with delete array, and if you just plain new, that should be paired with plain delete. Okay, so in summary, use new array and delete array to allocate and deallocate arrays. New array should only be paired with delete array, and delete array ensures the destructor is objects in the array created by new. Likewise, New array ensures that a constructor, normally a constructor that takes no arguments, will be called on all of the objects that were constructed.